Hello, my dear students. In our previous video, we learned about the properties of quadrilateral. Now, in this video, we will prove some theorems based on quadrilateral. The theorem is angle sum property of quadrilateral. What is this property? The sum of the angles of a quadrilateral is 360 degree. For that, we have drawn a quadrilateral ABCD. So, we will write what is given: the sum of the angles of a quadrilateral. A quadrilateral is given, a quadrilateral ABCD. A quadrilateral is given, and we have to prove that the sum of the angles is 360 degree. So to prove is angle DAB plus angle ABC plus angle BCD plus angle CDA equals 360 degree. For this, we make one construction from our side, that is shown with a dotted line. That is, we have joined a diagonal AC. Now proof. By this diagonal, the quadrilateral ABCD has been divided into two triangles, triangle ABC and triangle ADC. So we take triangle ABC. In triangle ABC, we have three angles: angle 1 plus angle ABC, this is ABC, plus angle 3. The sum of three angles of a triangle is 180. This is known as angle sum property of triangle. Whatever we write a reason against it in the bracket. Now, another triangle is triangle ADC. In triangle ADC, also we have three angles: angle 2 plus angle CDA plus angle 4, 180. This is also by angle sum property of triangle. So we can write here same reason. When we add equation 1 and equation 2, we will get angle 1 plus angle 2 from the second equation, angle ABC from the first, angle 3 from the first, angle 4 from the second, and angle CDA from the second equation. Towards the left side, towards right side, we have 180 plus 180, angle 1 plus angle 2. Angle 1 plus angle 2 together make angle DAB. So this is angle DAB, angle ABC as it is, angle 3 plus angle 4 is the angle BCD, angle CDA 180 plus 180 is 360 degree. Now another theorem is a diagonal of a parallelogram divides it into two congruent triangles. Clearly, there is a parallelogram ABCD, a parallelogram ABCD, a diagonal of a parallelogram. There is a parallelogram ABCD. It means a diagonal also is given. So that diagonal is AC. And this diagonal AC divides this parallelogram into two congruent triangles. This is to be proved. So to prove is triangle ABC is congruent to triangle CDA. Now proof. In triangle ABC and triangle CDA, angle 1 of triangle ABC is equal to angle 2 of triangle CDA. Why? Because these two sides are parallel, being the opposite sides of parallelogram. When these two sides are parallel, then angle 1 and angle 2 are alternate interior angles. So they are equal. AC is equal to CA. This side is common to both the triangles. Then angle 3 of triangle ABC is equal to angle 4 of triangle CDA because of alternate interior angles, as AD parallel BC being the opposite sides of parallelogram ABCD. Therefore, the two triangles are congruent by angle side angle. Okay. Now we have one more theorem, that is in a parallelogram opposite sides are equal. No? So given is a parallelogram ABCD, and we have to prove that its opposite sides are equal. AB equals CD and BC equals AD. These opposite sides are to be proved equal. For that, we make one construction from our side, that is join AC. Constructions are made with the dotted lines. Now proof. For this also, we'll prove triangle ABC and triangle CDA as congruent. So angle 1 of triangle ABC is equal to angle 2 of triangle CDA because of alternate interior angles, because AB parallel CD. AC of triangle ABC is equal to CA of triangle CDA, which is common. Angle 3 of triangle ABC is equal to angle 4 of triangle CDA. Alternate interior angles because BC and AD are parallel. Why they are parallel? Being the opposite sides of parallelogram. So, the two triangles, triangle ABC and triangle CDA, are congruent by the property angle side angle. If they are congruent, then we can say its corresponding parts are equal. So AB equals CD and BC equals AD by CPCD. Okay. Now one more theorem we have. If each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. This theorem is converse of the previous theorem. In this, we have a quadrilateral ABCD. The given is a quadrilateral ABCD. Each pair of opposite sides of a quadrilateral is equal, in which AB equals CD and BC equals DA. And we have to prove that ABCD is a parallelogram. For this also, we will make one construction. We join the diagonal AC. We have to prove this quadrilateral a parallelogram. So first we should know that how a quadrilateral can be proved a parallelogram. So my dear students, we have three things to prove. That is, if we prove that each pair, both the pairs of opposite sides are equal, then it can be said that the quadrilateral is a parallelogram. Secondly, if we prove both the pairs of opposite sides equal, then we can say that quadrilateral is a parallelogram. Then, if we prove both the pairs of opposite sides are parallel, then we can say that quadrilateral is a parallelogram. And thirdly, if we prove that any one pair, either AB and DC or AD and BC, any one pair of opposite sides is equal and parallel, then we can say that the quadrilateral is a parallelogram. So, we are given that AB and DC are parallel and BC and AD are also parallel. Very clear, AB equal DC, BC equal AD, AC and CA are common. So we can prove these two triangles as congruent triangles. So in triangle ABC and triangle CDA, AB equals CD. Why? Because it is given. AB equals CD, BC equals AD, This is also given. And AC equals CA. That is common. Therefore, both the triangles are congruent by SSS. When the two triangles are congruent, then the corresponding parts are equal. So angle A of this triangle is equal to angle C of the other, being the corresponding angles. So angle 1, that is angle A, is equal to angle 2 by CPCT, and angle C, that is angle 3, is equal to angle A, that is angle 4 by CPCT. Okay. So when angle 1 and angle 2 are equal, that is alternate interior angles are equal, so we can say that AB and CD are parallel. When angle 3 and angle 4, that is the alternate angles are equal, then you can say that BC and AD are parallel. When both the pairs of opposite sides are parallel, then we can say that ABCD is a parallelogram. That is, the quadrilateral ABCD is a parallelogram. Okay, that's all for this video. We'll continue the same topic, that is parallelogram, in our next video also. We'll solve some more theorems based on parallelograms in the next video also. Thank you.